So it's about augmented matrices. They're matrices with an augment, which means like an improvement or an add-on kind of a thing. All right. So first, let's review. Here are two problems. The first one is an adding, and the second one is a multiplying. You've got to make sure you remember how to do this. Try those two right now in your notes. It's a good review for your notes. I'll pause while you do that. So for the add one, we just use corresponding ones, and we just go the 2 and the -1 make what? 1. This is an add right here. So, and then a -1 and a +1 makes 0. And then a 1 and a 2 makes, and a 4 and a 3 makes. All right. This one, a little more complicated. We should really write out our spots. This is our map. R1, C1, row 1, column 1, row 2, column 1. And this is column 2, right? And row 1 and row 2. I don't know if any of you got used to writing it that way when you were doing it. That's how a great mind would do it. I'm just kidding. Okay, this is my map. It tells me row 1, column 1. So here's row 1, here's column 1. And I go 2 times the -1 makes -2. -1 times 2 makes -2. -2 and -2 makes -4. All right, now it saved me some time here. Mr. W, what did you get for the rest of them? What's this one? -1. -1. What's this one? What's this one? Can anybody?
No, 13 or 12.
Aha! Thank you. Okay. So that's just a quick review to make sure you remember how to do that. This is applications of matrices, and you're going to use this augmented matrix idea. Let's see how fast you can catch on to this. I get it totally now, although even this morning I was still like pulling all the pieces together. But I think I've got a lot of the junk you didn't need out of this so that this won't be too bad. All right. First of all, if I start with two equations, please write these equations in your notes. 2x plus y equals 5, 5x plus 3y equals 13. You got two equations. That's a system of equations. And that's the beauty of this. You can solve a system of equations, which is one of the main things you're supposed to know how to do according to the state of Minnesota, and according to us, and according to your next year's math teachers. You got to know how to solve a system. And we can do that by substitution or elimination, but it takes a while, needs a lot of work shown, and it's kind of a pain in the butt. But we're going to show you how to do it with matrices, and it's going to be really slick. All right, watch. 2 and a 1 and a 5. Where do you think those came from? The 2, the 1 there, and the 5. You get that? Okay, how about this? The 5, the 3, and the 13. Can you see them? 5, 3, 13. And then the last thing is that this is an x and this is a y. Now it might seem strange to you because both equations had an x and a y in them. So why do I like only have x's in the top row and only have y's in the bottom row? Well, if you understand matrices, you'd know that this must mean multiply between these two matrices, right? And if you multiply matrices, then a 2 by 2, and this was a what by what right here? 2 by 1 would work, right? The 2's match, and it would give me an answer of a 2 by 1 matrix, which is what this is. Get at that? Then, if I actually multiply this out, watch what happens. This is row 1, column 1, right? And this is row 2, column 1. Row 1, column 1, here's row 1, here's column 1. Multiply them out. What do you get? 2x plus y. And it equals that, because that's where it's supposed to go, right? Equals 5. Do you get that? All right, and then I can change to a different color marker and do the other one right here. And that one comes from row 2, column 1. Here's row 2, column 1. 5 times the x, 3 times the y, 5x plus 3y equals what? It's right there, 13. So this is just another way to write these equations so that if I actually multiply my matrices outright, I would get these back again. So all you have to know, though, is an even simpler format for it, where they just cut the x and the y out of the loop, and they just say this right here. 2 and the 1 and the 5, and the 5 and the 3 and the 13 are the key numbers, right? 2 and a 1 here and a 5 and a 5 and a 3 and a 13, and there they are. They're all in the right spots. You get that? And that is an augmented matrix because it's a normal matrix right here, but then it's got this line in here. Just kind of to sort of divide, that's where the equal sign would go. And then those are sort of the answers. So when you sum it all up, we had this. We had a system of equations, and we just plucked all the important numbers out of here and put them in here. And plucked all the important numbers out of here and put them in there. Raise your hand if you feel like you get that. Okay, good. Question. What does that accomplish? Well, all it accomplishes so far is puts my numbers into a matrix. Once it's in a matrix, then I can do something to solve that matrix. So we'll get there in a second. All right. Now that it's in a matrix, we can do something with your calculator, but we don't get the calculators out quite yet. I need to make sure you totally get this part. So that top one there, those numbers, those really mean a system of two equations. Would you please write out the two equations that top one means? I'll pause while you do that. Excellent. Okay, so now we've got our two equations, and I want you to write an augmented matrix. It should go like this. It should be like automatic. Go ahead, write the matrix for that. An augmented matrix. What'd you get?
3, 5, and then 1.
What's it missing? Good. All right. Now last, I want you to take that blue one, and this is the most important one. See if you can understand why when you write that in two equations, that's really important. Try writing the two equations. Figure out why that's special. So technically I should be writing 1 what? 1x plus 0y equals 5. Why is that so important? Because it's just x equals 5. And what does the other one just mean then? Skip over the boring part. Y equals 13. Good. So this is really powerful because this is your calculator's way of telling you that x is 5 and y is 13. If it wanted to tell me x was 10 and y was 12, I would just go like, it would tell me this. 1, 0, 0, 1, line 10, 12. And it just told me x is 10 and y is 12. Do you get what I'm saying? All right, because this is really writing equations. 1x, 0y equals 10, and 0x's and 1y equals 12. But it just boils down to x equals 10 and y equals 12. All right, so see if you can stretch your mind to handle this then. That means something very simple. That must mean that there's 1x plus 0y's plus 0 of something else, which was probably z. And so what does this really mean? X equals, y equals, and z equals 1/2. All right, good. Questions or comments? Yes. Nope, don't have to know what that is. That's just the augmented part of the matrix. Don't know the name for it if there is a name for it. This little line, it just separates off, and you know what? Don't even really need it. Put it back. See, that's kind of why they put it there, because it does make some sense. It separates off the answers, but your calculator knows that that line really doesn't do anything, so there, see? It's the same thing as not having the line there. It just augments it by like helping you to see that that's where it is equal to whatever. Okay, yes. No. What I told you before was that we would be able to take a word problem, for instance, that would have 3 equations and 3 variables. Remember how long those were to solve? when you had 3, and I even only gave you easy ones. This can take ones that have three complicated equations, and you could put it in a matrix like this, and then your computer can go bing, get the answer really, really quick.